And Chris, you have a very bold topic today, right?
It's a wild claim.
Yeah. You're going to tell us about 3 steps that you took to get the fastest e-commerce search in the universe on Bike24.
Exactly.
All right, well, take it away.
All right, well, thank you for that introduction, Chuck. I am Chris, as you've just heard. I'm a software engineer for Bike24. And today I'm going to be talking about how we refactored our integration with Algolia to achieve perhaps the fastest search results page in e-commerce in the universe. So this is the page. You can see we've not reinvented the wheel when it comes to design or functionality. This search has about 6,000 products, but we've got about 100,000 searchable products in total. And they're across all sorts of different things. We're selling components, we're selling bikes, we're selling clothing. And with a wide range of products, we need a lot of different filters too. So right now we've got 190 implemented, but I think there's something in the sprint this week to bring that up to 500. And you can see as I'm navigating the website that it's pretty responsive, right? If you do a lighthouse test, right now we're getting a 99, which I think is a fair assessment of where we're at. Obviously, there's some variation with lighthouse tests, so sometimes you might get the magic 100. And you know, it's green across the board. Is that enough to be the fastest e-commerce search results page in the universe? Well, the word e-commerce is maybe doing a lot of work in that claim. If you compare our search results page to other search results pages in e-commerce, actually you'll realize that there don't tend to be very good metrics for this type of page. I performed this test under the same conditions here for Amazon, Decathlon, Nike, and you know, 99 is actually quite far ahead of these other examples. And we've run these tests for many other e-commerce pages too. I've chosen these ones because Decathlon and Nike use quite a similar tech stack to us, I think. So it kind of shows that it's not just the tech you're using, implementation matters. And these aren't just numbers either. If we watch how the pages load together, you can see that Bike24 is delivering or is rendering results much sooner than the other pages. And it's kind of fun to see the different loading methods that everyone uses. This is just to kind of give it a sense of what the user might see rather than just a number. And I said implementation is important, and that's because when we started with Algolia, our implementation was actually much closer to Nike's score than it was to our current. And so what I'm going to do now is talk you through how we refactored our implementation and went from quite a poor score to quite a good one. So to understand where we started, I think it's good if we could kind of follow a request through the system. And of course, a request begins with a user typing a search term into their browser. And the browser triggers a request to bike24.com. We've got a NextJS app using the app router. And we're self-hosting that on Google Cloud Platform. So our request or Next.js app responds with some HTML, some CSS, and some JavaScript. And in that JavaScript, we've got our Bike24 UI. That's all of our kind of custom styles and custom functionality. And we had started out by implementing that UI on top of Instant Search. So we have an Instant Search React library to kind of form the glue between Next.js and Instant Search. And then Instant Search is kind of like a middleman between the UI and Algolia searches kind of API clients. So Algolia Search Helper is an API client which kind of does the higher level stuff. And then Algolia Search is their core client, which handles the HTTP request. And in our case, we wanted to hide our API keys. So that HTTP request was sent to a Cloudflare proxy. And that proxy added the API keys, sent them to Algolia servers. Algolia did its magic. It generated some results for us. And the request goes back through the system until the browser is able to render the search results to the user. So quite a lot of moving parts in this system. And the reason we built it this way in the first place is because Instant Search is a great way to get started with Algolia. you can basically copy and paste some components into your app, and it manages all of the kind of generation of those requests to Algolia's servers. But as we were looking to implement more custom functionality and more custom UI, we found that our UI library was starting to kind of fight a little bit against instant search. And also the magic of instant search, which are these kind of self-configuring components, was starting to provide a little bit of friction for us as well. Our front-end devs were having to really understand what was going on with Algolia. They were spending a lot of time reading Algolia docs. And this coupling of the front-end and back-end concerns was making it a little bit painful for us. And so we decided to refactor to try and make the system simpler for our needs. And this was basically, in the first instance, thinking about removing instant search from the system. So I can show you a little bit about the kind of refactoring we did to achieve this. As I've mentioned, Algolia Instant Search uses these components in the UI to configure the search. So the first thing we did was take out that magic and create a sort of one source of truth for the configuration. And this holds all of our filters and any other config that's needed to perform the search. And then we replaced instant search with a hook, which is kind of the React way of doing things, called useSearchState, which receives the config and gives us some state back. And these filters and product list components previously were smart components. They were deciding which filters were going to be sent on the Algolia request. But with this system, we were able to make them into just dumb UI components. So they're just rendering elements based on props. And this is, for us, a much simpler way to implement the system. It means that we can cut the link between front end and back end a little more clearly. Of course, useSearchState does have to replace everything that instant search was doing, but it turns out that we don't have to do too much. We basically created a custom wrapper around Algolia Search Helper, and that gave us a little helper method to execute searches. And what was left was a way to take the results of those searches and bring them into our React state. And React has this wonderful hook called useSyncExternalStore, which allows you to take some external state, subscribe to it, and then get that state with a couple of helper functions. And it returns some state which exists in the world of React. So to make life easy for ourselves, we made our Algolia client return those helper functions. And we were pretty much able to get the whole thing working, replace two libraries with 2 lines of code, which for us was a big win. Of course, there is something happening inside this custom Algolia client, and this is where the refactor does get a little bit awkward. You can see here that the client mostly consists of an instance of Algolia Search Helper, which we've configured with some search config. And then we expose our own search functionality, which, the helper does all the heavy lifting here. We're really just providing the glue. And you'll notice that this search function, it doesn't return anything. And that's because Algolia Search Helper has an event API. So we need to listen for results on the helper. And that's how we can update our store, which then we expose to the world of React. So it's a little bit more awkward here, but you can see there's not too many steps required to get something working. And if you didn't follow all of that too well, don't worry, I'm going to show you visually now. What we did was we took instant search out of the system. We replaced instant search React with our useSearchState hook, which uses useSyncExternalStore under the hood. And then we kind of glued it all together with our custom client. And that meant we had a lot less code. And it's important to be clear, we have less code because we care about less than instant search. When Algolia is producing instant search, they need to do a lot. They've got many features, they've got many frameworks. But Bike24, we've only got one framework. We're only using a subset of those features, so we can write less code. We also have less complexity for the same reason. Algolia is solving difficult problems, but Bike24 is solving pretty simple problems. So we don't need to rise to the same level of complexity that Algolia's libraries do. And finally, we've cut the tie between front end and back end. Our front end devs don't have to worry too much about how the UI might affect the requests anymore. There was a downside though, because our UI had been built on top of instance search, we had to rewrite all of those components. But I think that's a good trade-off, because what we like about Algolia are its search results. We don't really need them to render our checkboxes for us. So that was the first iteration in our refactor. And to be honest, this is 80% of the value for 20% of the work. You could stop here. The code is performing well, and the code is easier to work with. But at the time that I was building a little proof of concept to demonstrate this approach, our former head of product, Christian Sieler, was also building his own proof of concept, and he was implementing server-side rendering. So it's important to note that server-side rendering does have trade-offs. I think Algolia recommends client-side requests because they do a lot to make those fast. But we were thinking about using the system for pages that need to be pre-rendered for SEO reasons. So we were willing to take on that extra burden. Unfortunately, server-side rendering, not that difficult to implement with Next. Basically, all you've got to do is take all of this stuff that's going to the client and move it to the server. Unfortunately, we lose use search state because that's using use sync external store under the hood, which is a client API. But we also don't need the Cloudflare proxy anymore because we're never going to send those API keys to the client anymore. And refactoring this, it only takes a couple of extra lines of code, to be honest. You make your client component a server component. And then that means that you can create your client directly in your component. And then you can run the search method. It's pretty common to get the search term from the parameters. And I guess we've got to await this probably. And that's it. You don't need to change the UI because the UI is just dumb components. If you're following very closely, you might remember that search didn't originally return anything. So you have to refactor this client a little bit. But for the most part, the code changes are not that dramatic, which I think kind of indicates that our code is nice and flexible too. It wasn't perfect though. Algolia's code is really written with client-side rendering in mind. And so we had to quite carefully optimize memory usage to ensure that everything ran correctly. And React Server components, they're kind of a new paradigm. So our front-end devs who were avoiding reading the Algolia docs suddenly had to spend a lot of time reading the NextJS docs instead. On the plus side, our servers and Algolia servers, I think they're in the same data center. So there's almost no latency when they talk to each other. And we ended up with really efficient CPU and memory usage. So we didn't have to scale up our resources for Black Friday or Cyber Monday, which is pretty cool. And again, you could stop here. You've got a lot of value, you've got a lot of performance, but we kind of thought the cherry on top would be to take one extra step and remove some of this awkwardness around Algolia Search Helper. So we moved that logic into our own client. And this is kind of 80% of the work for 20% of the value. So you should only really do this if you really want to. But for us, it opens the door to kind of new innovations that we're quite excited about. So we took that extra step. And I'd love to talk more about it, but for time reasons, that's kind of as much as I can say. With this final iteration, which is what you will experience if you visit the Bike24 search results page, we achieved exceptional performance, what I like to claim is the best in the universe. We are really fast at developing new features. Because we've got so much control over how we generate requests to Algolia, we are able to really do some cool stuff. So keep an eye on the page, you might see some cool stuff soon. Our conversion rate improved. There's a lot of material online about how better performance can result in better conversion rates, and our experience was consistent with that. But also, interestingly, our Net Promoter Score improved. We had a survey before we made these changes, And we had, unfortunately, the worst Net Promoter Score in the company for our page. And that has now since changed to being, I think, the best one. So that really underlines how users care about performance. It makes them happier to use the website, and it makes them buy more stuff, which is pretty cool. And it also goes to show how implementation matters. Our system now has got far fewer moving parts, and it's easier for us to work with. And that's the end. All that remains for me to say is thank you very much to the team that built this. Misha, Toby, Nante, Arya, and Batul. It's a pleasure and a privilege to work with each and every one of them. And thank you to Algolia for giving us the platform to talk about this. I hope that you have maybe gained some ideas or inspiration for how you might refactor your own integrations. So thank you very much.
Awesome. Thank you very much, Chris, for sharing this with us. I think definitely some interesting sort of non-traditional approaches here that I think could be useful to other folks. I will say that there are lots of comments in the chat around your slides themselves. People are very fascinated with the software that you use. So maybe after you're off stage, you can share a little bit about that piece of it. We've got a lot of front-end developers, and I think they appreciate your React-driven slides. But we do have some questions as well. The first one came from Vladi. And I don't think this was sort of a previous iteration, but Vladi was curious about your use of a proxy. What brought, I think you had a Cloudflare proxy in the mix. And I know you mentioned a little bit about API keys. Can you talk a little bit more about why you were using a proxy and if that's still being used in the current design?
Yeah, of course. So we don't need the proxy anymore because we're not sending our API keys to the client at any point as a result of using server rendering. I suspect we might have never needed the proxy, to be honest, but it was just there as a way of masking the API keys from the end user.
Mm-hmm. And I should emphasize, Algolia, we've got a fairly mature concept of keys. You should never be using front-end admin, or you should never be using admin keys or keys with write access in the front end. We provide you with search keys, or you can actually even scope keys even further down. But, it's always good practice, and I know as developers we hate to expose keys if we don't have to, so I appreciate that piece of it. Let's see, the next question we have is from David, and David wanted to know where the pricing information was coming from. Was that coming from within the index or from an external source?
That's a great question. Pricing is a little complex for us because we need to know the delivery location of the user in order to apply tax and things like that. So we get the prices from Algolia, but then we need to change them based on their country. And their country comes, we're detecting it from Cloudflare, I think. It comes from a cookie. So we do some clever stuff. I think if you join the page and you haven't got a cookie set yet, the prices will be client rendered. But if you've already got that information, if you've got it all at the beginning of the page load, then they will be present in the initial payload.
Okay, good to know.
So we're combining streams of information there.
Right. And that's typical, right? You think about inventory, you think about some of the other pieces too. You want to make sure that you've got just enough information in your index to be able to render good results. But you're probably going to end up having to enrich that with, additional sources as you move to product detail pages, I would imagine.
Yeah, and I think we probably will end up with prices outside of Algolia. They're there at the moment because it's a convenient place to put them. But as our pricing system matures, we'll probably want to have a pricing service that's dedicated to that.
We had another one from Vladi. They were interested what platforms you support. It looks like this is mobile. I mean, this looks like this is web. Do you have to support mobile, or do you have any other platforms that you need to sort of support for your users?
Not really. I mean, we have a responsive design, so it should work well on mobile. And actually, it feels even faster on mobile because you can't see the results loading. The changing the filters kind of blocks the load. But there's no native app or anything like that. Although the performance is good enough that it kind of feels native when you're using it. Right on.
A question from Pragya. Did your backend language /stack help in moving to server-side rendering?
Yeah, for sure. I mean, NextJS has server-side rendering as its preferred way of rendering components, I think. So we didn't have to fight the framework there. It was more a case of updating our mental models to match this new React server components paradigm.
Got it. Got it. And then one more question. We kind of dug into this already, but Warren wanted to know how much data do you keep in the index versus hydrating search results with external data? So I think we talked about that a little bit, but
yeah, I mean,
give a
so
percentage maybe.
yeah, well, it's hard to give it a percentage. I mean, obviously, there's a limit on how much each record should contain data-wise, right. And I think we try and keep it to the minimum. Hard to answer that question. I think probably the majority of it does come from Algolia, but we do have to enhance from various different other API calls. I think we've got maybe 6 or 7 API calls that happen in order to render the page.
Okay, good to know. And we're going to unfortunately have to move on to our next presenter, but Chris, maybe you can hang out and say hi to some folks in the chat. I know that they definitely had some interesting questions. So,
all right. Well, thank you very much again, Chuck, and best of luck to the other speakers.
Awesome. Thank you, Chris.